directions for example 2 are, I would say, probably the most confusing directions that the author chooses to use in this textbook. So it sometimes takes a while to read through these directions and make sure that you catch what's happening. So what I'm going to suggest is that you pause the video, read through the directions for example 2, and then we'll talk about what you just read. So the first thing to note about those directions is that the author is simply saying there are 2 lines. There's line 1 and line 2. But in order to differentiate those 2 lines, he says that we're going to call these lines L for line, and then he puts a subscript on each one of those. So we have line 1, and then we have another line, and he calls it line 2. So now that he has that information, that we have 2 lines running around, he then says, oh, is line 1 going to be parallel to line 2? Is line 1 going to be perpendicular to line 2? Or do we happen to be in a situation where we are neither parallel nor perpendicular? So that's what this problem is really asking us to do. It just gets a little muddled when you look at all of that information in terms of his directions. So let's see what the author tells us about each one of these lines. So line 1 has 2 points on it. Line 1 has the point 3, 5 and the point 9, 1. Well, if those are 2 points that are on this line, I know that this idea of parallel and perpendicular is associated with slope. So we can calculate the slope of this line. Now remember, we have a formula for slope. M is going to be rise over run, but we also have that version where it's y2 minus y1 divided by x2 minus x1. So when we look at these 2 points, we have to decide who's point 1 and who's point 2, and then move forward. I'm going to say this is point 1 because it's the first one that was given to me. That means that we have an x-coordinate here called x1 and a y-coordinate here called y1. This is then going to be point 2, which means we have the x-coordinate of x2 and the y-coordinate of y2. So the slope of my first line, I can call that m1, and that's going to be y2, 1, minus y1, 5, divided by x2, 9, minus x1, 3. Well, 1 minus 5 is going to be negative 4. 9 minus 3 is going to be 6. Now remember, once again, you always simplify your fractions. So negative 4 over 6 can be reduced down to negative 2/3. So the slope of our first line is negative 2/3. Well, now that we know that, let's go ahead and see what we know about line 2. The author has told us that line 2 has 2 points on it as well, and those 2 points are 4, 0, as well as 6, 3. Once again, you choose who's point 1, who's point 2, and then move forward. I'm going to call this point 1, I'm going to call this point 2, and I'll do some subtractions here. The slope of line 2 then is going to be y2, which is 3, minus y1, which is 0, divided by x2, 6, minus x1, which is 4. 3 minus 0 is going to be 3, 6 minus 4 is going to be 2. So what I now need to do then is look at my slopes and figure out which world we're in. So M1 and M2 are not the same number. That means my 2 lines, L1 and L2, are not parallel. Well, let's double check to see if they are perpendicular. Remember that in order for these 2 lines to be perpendicular, their slopes have to be negative reciprocals. If either one of those words is not being demonstrated, we are not looking at perpendicular. So negative means that one has to be negative and one has to be positive. There has to be a sign change. We have one that's negative, we have one that's positive, we have that sign change. So we have a check mark on negative. The next word is reciprocal. It means that the fraction had to be flipped. So we have 2 over 3 here, we have 3 over 2 there. The fraction has been flipped. So that means we have reciprocal as well. Check mark for reciprocal. So since we have both negative and reciprocal in play here, that means that L1 and L2 are perpendicular. Whenever you're doing this kind of problem, make sure you finish the problem. Don't just go through the slope calculations and stop. Make sure that you actually answer the question that was requested. So your final answer should be one of 3 words: parallel, perpendicular, or neither.